Good morning, Primary 6. Good to see everyone. It is Friday the 15th of May. And good to see everyone here. Just looking through the comments. Eva, you were first up today. Good to see you. We've got Hamish, we've got Karina, we've got Aisha, Freddie, Lucy, Isa. Fantastic to see all of you guys tuning in. Amira, good to see you here today as well. So quite a lot of us already. We're already up at 13. Plan today, guys. I've got a few announcements to make. Just little faffy things for us to go through, but just a few things that we need to clarify. And then we're going to talk, for the most part, about space today. Space, the final frontier. That's pretty much the plan for today. Let me just get up my notes. Now, first of all, can you guess where I am today? This is quite a famous landmark in the world, and I think really quite cool. If I move, I can never tell which way to move. I think if I move this way, you might be able to see more of what's going on here. No, it must be the other way. Remember, I'm on a lag, so it takes a wee while for things to catch up. Here we go. Can you guess where I am? I think this is a rather fantastic geological feature, something that I find really quite interesting. Kind of ties into our structure of the Earth topic. Check that out. Isn't that awesome? This is... Now, my pronunciation is almost certainly going to be off, because I am not from Norway. But this is the Kjerabulten, I think. Kjerabulten. I believe it's in Norway. Now I'm doubting myself. It's certainly somewhere in Scandinavia. Kjerabulten. It is in Norway, yeah. So the Kjerag is a mountain in Norway. And we can see here that there's this really quite large boulder that is trapped between them. Now, you can fit people on that. So there's lots of pictures online. If you look for the Kjeragbolten just on a Google search, you'll find boundless pictures of people basically standing on that and probably hoping for their lives that it doesn't give way. Rosalind there has just posted the correct spelling. You just beat me to it there. So well done. So if you're wanting to look any of this stuff up, then have a wee look on Google for the Kjeragbolten, because I think it's quite a cool little landmark there. Now, it is school jumper day, or basically school uniform day, so give me a shout out in the comments if you're wearing school uniform. I figured I would dress down today since you guys are dressing up, so that it balances out. So I am going tieless today, but hopefully you guys, just for a bit of fun, are wearing your school uniform, just for a bit of solidarity, a bit of a sense of still being a D-mainser, as it were. Give me a shout out if you are wearing your jumpers. Yeah, we've got quite a lot of us here saying that they're wearing their school jumpers, so that is great to see. I might post an old embarrassing school photo of myself on Teams later for my class, just to show that once upon a time I was but a humble school child myself. So I'll see if I can post that up later. We might, if we do, when we do Philosophical Fridays later, I might throw up a photo of that just for your amusement. I managed to get my dad to drop two old photos outside my door just a couple of days ago. Anyway, guys, stuff that we need to go through. Let's have a quick look. So, first of all, please, I am begging you, wherever you can, post work to the class notebook. Okay? The class notebook is the main place that I'm giving people feedback on their work. So, loads of you have been doing it. I say loads of you, not as many as I would like. There's probably only around 10 of you in my class that are regularly posting stuff to the class notebook. The rest of you either aren't sharing it at all or you're still posting it in the general area. Now, I know one or two people that have valid excuses, but most of you, really, you should be trying to post it on the class notebook. Now, it's really important because of two main reasons. One, I can give you feedback. Some of you I've been giving audio feedback to, which I'm hoping will be useful. In fact, could you please give me a shout out in the comments if you have been able to read my feedback or even hear my feedback in some cases, because it would be really nice to know if you're actually getting the feedback, if you're noticing that, because I'm basically every night I'm going through all your work and posting a wee bit of feedback on it. So let me know. Sky's saying that she's posting, and yet I haven't noticed it from her. So I'll need to check up on your one, Sky, because for some reason it doesn't seem to be alerting me when you're posting. But that'll be why you haven't had any feedback then. So I'm gonna need to check your one, Sky, because literally haven't noticed anything that you've put up. Jessica, I've given you a couple of voice notes, so you should have had some voice notes. They're in a little embedded audio file, so have a look for them. It should be a file that you can download. There's some people saying that they're not getting feedback, but I've been giving quite a lot of feedback. Okay, right. I wonder if there's an issue then. Maybe that. Freddie, I've given you some feedback on some of your work. Rosalind, I'm pretty sure I gave you some feedback earlier. So what we'll need to do, we'll maybe talk about this in the Philosophical Friday session later. But it looks like there might be an issue then, because some of you that I'm giving feedback to are saying that you're not getting it, and then there's other people that are saying that they're posting stuff, and I've never seen any of your stuff up there. So. Oh, Sky, did I say that you got it? Did I say that I got your work? I don't remember seeing it. I'll need to go and double check again. Anyway, but everyone, get your work posted to the notebook wherever you can, because it's definitely the best way. Maybe I did then, Sky. Sorry about that. I'm misremembering. This is the thing. So many people posting so much work, it could be hard to keep track of. But there's certainly some people that are missing from it. Aya and Amira. It's like the most obvious thing. If you're saying that you can't find the notebook, you need to look harder. It's at the top of the general page. It says, when you go to the general channel, at the top right, it'll say class notebook. And then you've got your own little sections in there. That's where you post your work to. Okay? Right, guys. Okay, so that's something that we need to smooth out, but hopefully that'll get smoothed out shortly. Other things that we need to announce. This Monday is a holiday, so I will not be able to do my group meetings on Monday. So the 3 groups that I would normally meet on Monday will meet at the same time on Tuesday instead. I'm not going to live stream on Tuesday, so I'll not be doing a live stream, but I will be meeting up with those 3 groups instead. Okay? There is now also a school YouTube channel. So if you've subscribed to me, also subscribe to the school YouTube channel if you can. If you run a search for Davidson's Mains, you will probably find it somewhere there. But there is now an official school YouTube channel. They've not released any videos yet, but Mrs. Gracie is going to be posting up a... sorry, I'm getting distracted by the comments in the live stream. Mrs. Gracie is going to be posting up an assembly, a proper online digital assembly, probably next week at some point. So if you subscribe to that, you'll get alerted when that comes out. It's already uploaded, we've just not made it public yet. So make sure that you are subscribed to the school YouTube channel so that you can see that when it comes out. The name of the school YouTube channel is literally just Davidson's Mains Primary School. So if you type all that correctly, you should get an alert about, or you should be able to find the Davidson's Mains YouTube channel. Very quickly, another couple of things. Wolf Brother, make sure that you're getting a copy of that if you can. And lastly, a happy birthday to Archie today. Archie, a very happy birthday, mate. Hope you have a good one. You're probably not even watching this, nor should you be. You should be away, like, partying and, doing fun stuff. But happy birthday to Archie there. Okay, right. We've got a few things to talk about space-wise. To be honest, this is just stuff that I find interesting. I'm just going to spraff at you for a little bit about stuff that I think is cool. So first of all, you did an activity this week about which planet would win in a fight. So you all had your own. This is just a bit of a silly topic, but hopefully it made you think about things in a bit of a different way. You were all given a planet to research, and the job that I gave you was basically to say, whichever planet you were given, why it would win in a fight over another planet. Now, loads of you came up with all sorts of different facts here. Who would say that their planet, the planet that they had, was the best planet, the most interesting planet? Give a shout out for your planet in the comments. If it was Neptune, if it was Uranus, if it was Jupiter or Saturn. Have a shout out. Which planet is the best one, guys, in your opinions? Yeah, hopefully you all managed to do a little bit of research on it, and hopefully you enjoyed the task as well. I mean, the slightly quirky activity of why this planet would win against another planet. Obviously, it's a ridiculous idea, but it makes it a bit of fun. It makes you think about it in a bit more detail. Now, my personal favourite planet, other than Earth, of course, because Earth is just magnificent. But my next favourite planet, I would say, is Venus. I think that Venus is a pretty awesome planet. And I'm going to tell you a little bit why. So some of my favourite facts about Venus. It's got a very, very slow day. Its day takes over 200 hours. 200... is it 200 hours? 200 days? I've actually forgotten. Day length... Good thing is I can just Google all this right here. I'm sure it's days, isn't it? Oh no, right, it's 116 days. For basically a day on Venus lasts 116 days on Earth, which is an astonishing amount of time. So it's the longest day of any other planet in the solar system. So that and obviously it's turning really, really slowly, which. That makes it sound a bit boring, a bit sluggish. But actually, Venus is a hot furnace of a planet that is just burning with... it's just fantastic. So, even though it's not the closest planet to the Sun, because Mercury is the closest, Venus is the second closest, but Venus is actually hotter than Mercury. Let me know type a wee thought in the comments if you can. But can you venture an idea as to why? Why do you think Venus is hotter than Mercury when Mercury is much closer to the Sun? So why do you think it is so much hotter on Venus? Other cool things about Venus, though, it's so hot that in many places the ground itself is basically just lava. It's molten hot in places. So it's a very volcanic planet, and that means that we've not really got a good idea of what the surface looks like because it changes so often. It's so sort of plastic, so malleable, so moldable that the surface of Venus is always changing. So it's not like you can say, oh well, that mountain's there and it's going to be there for millions of years. It changes quite a lot all the time. It's also got extremely thick cloud cover, and the clouds are highly acidic. So there is, I think it's, does it rain sulfuric acid there? I think it's sulfuric acid it rains on Venus as well. So really quite astonishing stuff on Venus. And we've got the correct answer from, I think that is Zach there. So why is Venus so much hotter? It's because it has a much thicker atmosphere. So Mercury has no atmosphere. Mercury has no atmosphere at all. So that means, yes, it gets roasted by the sun all the time, but then heat escapes very easily as well. what atmospheres are they're like big blankets around a planet. So they let heat come in, but they also don't allow all the heat to go back out. So when the sun heats up Venus, at night, when half the planet turns to be nighttime, the heat would normally try and escape, but it bounces back in because of the atmosphere. So the thick atmosphere of Venus basically traps heat in. Its atmosphere is made up of a lot of carbon dioxide, and actually Venus was one of the things, or is one of the planets, that gives us a bit of a warning about the potential of global warming or climate change. Because if we keep putting carbon dioxide into our atmosphere at the rate that we're doing, then would it be possible for us to end up with a sort of Venusification, if you like, of our planet? Would it be that we end up with so much carbon dioxide that actually we end up causing the same sort of greenhouse effect, the same warming effect that is happening on Venus? Probably is the case. But here's a cool thought. What if we were able to find a way of getting all the carbon dioxide out of Venus's atmosphere? It might become habitable. We might be able to live on it. So this is what's called terraforming. And this is a genuine idea that's been proposed. Now, there's lots of people saying, well, we should terraform Mars. We should try and get extra oxygen in Mars's atmosphere. Personally, just from the stuff that I've read, and I've read quite a bit on it, Carl Sagan was big on this. He was one of my heroes. Carl Sagan sort of said, Mars, no, you don't want to pursue Mars. Mars isn't the way to go. Neptune, I'm reading people's comments here. Don't colonize Neptune. Venus is probably the easier one to terraform. Venus is probably tameable, as it were. One of the other problems with Mars, so Elon Musk is obsessed with the idea of going to Mars, its soil is full of something called perchlorate, which is a very, very toxic chemical, which means that the chance of us ever growing stuff there is very, very slim indeed. Whereas Venus, if we were able to solve the acid problem and the heat problem, which you can do just by, well, in theory, easier said than done, but theoretically you could do, you would then be able to make the entire planet habitable. So I think that's quite a cool idea. And Sky, you are right, Neptune is cool. It's very, 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 very cool indeed. Anyway, guys, so that's just a wee rant about my favourite planet there, but I thought you might like to hear that. Next thing that we're going to talk about. So, Venus, cool planet. Audrey, earlier in the week, shared a really cool video. Now, it would seem that her link has since broken for some reason. So what I'm going to do is I'm going to share the same video. I was able to find it somewhere else. And I'm just going to play it for you guys just now. Now, the whole video is about 5 minutes long. We might not watch the whole thing. But I strongly advise you guys to go and watch it at some point. Now, I'm going to turn the sound off for it. And I'll leave it just sort of playing in the background. So here we go. Right. So this is called Universe Size Comparison 3D. And all it basically is comparing the different sizes of different objects in the universe. But I love the way it's done. I think it's really, really effective. Hopefully this won't glitch out too much here. You never know. There might be a chance of it. But this is Ceres, which is a dwarf planet. I'm hoping that actually I'm going to pause it a second. So this is Ceres compared to the moon here, and I'm going to go out to full screen because it's important that I can. Oh no, it's frozen. See if I can just make it a bit bigger, but not full size. That'll do, because I want to be able to go between different windows. So that's the moon there, which is obviously a good bit bigger than Ceres. And lots of these are just different either moons or... So I think that's another moon there. I can't remember what is it one of the moons of Venus? Callisto? I can't quite remember. But here we're into the size of planets. So we've got some moons, Callisto, which are almost the size of planets, like Mercury. And the definition between them is quite complicated. What makes something a moon? What makes something a planet? So here we have Mars, which is not particularly huge in terms of planets, but you know, it's kind of our little brother, if you like. You know what? I'm going to speed up the rate of this video, because then we will be able to get through the whole thing. So you can see Venus and Earth, very similar sizes, which is quite cool. Now, this thing here, Kepler 22b, this is what's known as an exoplanet. Exoplanets are planets that are around other stars. So not our sun, but other stars. And we know they're there, we've seen them. I think this is one that's known as a super Earth. So it is a rocky planet. And now there's a short list of ones that might have life on them. So there's what's known as the Goldilocks zone, which is where you're not too hot, not too cold. You're just right. So you're in the part of the distance away from a star that basically liquid water can exist. So Kepler 22b is an exoplanet that we reckon has liquid water on it and therefore could have life, which I think is pretty awesome. So one day humanity may be travelling to Kepler 22b. Let's keep going. So it's a good bit bigger than Earth, though, which would mean more gravity, which means we'd be feeling crushed much more. So we'd need to get used to that. Neptune and Uranus, all quite big planets. But now we're getting up to the gas giants here. So we can just see how much bigger Saturn and Jupiter are compared to all the other planets. But then if we compare those to the Sun... Oh, no, this is not the Sun. This is Proxima Centauri, which is a star. And you can see it's not much bigger than Jupiter. I mean, it's much heavier than Jupiter, a lot heavier than Jupiter. But in terms of its diameter, how wide it is, it's not actually all that much bigger. Now let's compare that to, I think the Sun is coming up next. Yeah, so look at that, all our tiny little planets here compared to the Sun. I mean, Jupiter is huge compared to us. We can fit inside the red spot in Jupiter, the hurricane that's going on in Jupiter. But compared to the Sun, we are infinitesimally small. But now we get into some of the other things in our universe. So these are other stars compared to us. So Sirius A, Vega. Look how much bigger they are than our Sun. And we're nowhere near done yet. Arcturus, which is visible in our sky. So a red giant or a red hypergiant, colossal compared to our Sun. Rigel, even huger. Is it Rigel or Rigel? I'm never sure how to pronounce that. Now, Betelgeuse, this is one that's in Orion. It's one of the stars in Orion. So if you look for Orion's belt, 3 little stars in the sky, and then there's a few other dots around it. One of Orion's, it's either Orion's arms or legs, is Betelgeuse, which is this star here. And they reckon it might go supernova. Basically, it might explode pretty much at any moment. Certainly within the next million or so years it's likely to explode, but who knows, it could be in your lifetime. It's been showing some warning signs, so that's something to be very excited about. And if it was to explode, it would be bright enough to be seen in the daytime. It would be so bright that you could actually see it during the day, and certainly at nighttime it would be the brightest thing in the sky, which is kind of cool. I'm just going to look back at the live stream just a second, so hang on just for a bit. I'm hoping you guys are all able to see this, that you're able to actually see what's going on. Good, yep, we're all still tuned in. We're just checking because it's kind of hard to keep up with things. Now we're getting to some of the biggest stars that are known about. So this is UY Scuti. UY Scuti, I believe, is currently the largest known star. And now we're into what are called supermassive black holes. So supermassive black holes are some of the biggest single objects that we know about. So at the centre of lots of galaxies, in fact they reckon probably at the centre of every galaxy is a one or maybe several supermassive black holes. Now these are incomprehensibly huge. I mean, just running through this again, like if we compare the Sun to Sirius to Vega, and you know, is this Arcturus here? Like, just look how small our sun is compared to Arcturus. And Arcturus compared to these larger red hypergiants, I mean, the scale is just incomprehensible. And now comparing that to a supermassive black hole, we're talking ridiculous sizes of object. Truly incomprehensibly large. And there's even larger ones as well. Now, beyond this, these are what are called nebula. This is where stars are born. So, nebula, or nebulae, are big clouds of gas that are in space. So there's several nebulae. I think there's a few nebulae in just in our galaxy, the Milky Way. But they're like star nurseries. So in amongst here, occasionally, stars might burst into life. The gas swirls together, gets hotter, gets denser, packs together, and then the atoms that are inside it start smashing together and creating that nuclear reaction to turn it into a star. Which is kind of cool. And they come in all different sizes. I mean, the Helix Nebula, 3 light years across. I mean, that's a huge thing. The Orion Nebula 24 light years across. And from here, things just, excuse me, they get out of hand. It's too big to comprehend. It's already too big to comprehend. But anyway, I thought that was a really cool video. I'd encourage you to go and watch the whole thing if you can. Yeah, kind of awesome. Let's come back to the camera here. Right. So hopefully you found that stuff pretty interesting in the chat. They've all got rather weird names, a lot of these things. So you've got things like, so Betelgeuse, I think that actually comes from Arabic, I think. A lot of these stars have Arabic names. In terms of how do we know about this, it's kind of complicated to explain in a video, but there's a few ways that we can measure the size of stars. And this is definitely too complicated for primary level, but I'm going to try and explain a couple of things. One of the things you can do is you can look at things that are going around the star and the way that they're orbiting. Because remember, gravity is caused by mass, by how heavy something is. So if something's heavy, it has more gravity. And you can look at the way things are moving around it to tell how much gravity is there, and therefore how heavy it is. So that's one way. You basically almost weigh the star. You can weigh a star by looking at its gravity. Very heavy stars can actually bend light. So our black holes in particular, they're so heavy that light passing near them gets bent. So it means that, let's say my hand was a black hole and I held this cup behind my hand. Now normally at the moment you can't see the cup. It's behind my hand. But if my hand was instead a black hole, what you would see instead is you would see parts of the cup on the outside of my hand, because the light coming from the cup would shine towards the back of the black hole and then be bent around the black hole. So you'd be seeing little bits of the cup at all different angles, which is kind of weird. So that's how black holes work. They're so heavy that they allow you to see things that are behind them, which is kind of awesome. So yeah, I think that's a pretty fantastic fact. So that's one of the ways that we can measure things in space. Another way that we can measure things is to do with their brightness. You can tell certain stars, if they're a certain brightness, you know how big they are. So you've got ways of measuring them based on the way other objects go around them, based on their gravity, based on their brightness, tells you how big they are. And one of the other ways is something called parallax. So you can measure distance, how far away things are from us, using parallax. So if you hold your finger in front of your face, you can all try this, and you close one eye and then close the other eye alternately. You'll see your finger appears to move from one side to the other. Okay, so that is an example. What you're seeing there is something called parallax. One eye is seeing it from one angle, the other eye is seeing it from the other angle. In space, we also experience parallax. So let's say here's the sun and here's Earth. if we take a picture of a faraway star, let's say you are a faraway star, we take a picture of it here, and we see that the star appears there. Then 6 months later, we see that the star, we're now taking a picture from over here, and we see that the star looks like it's moved a little bit. That lets us know how far away the star is. We can figure out, it's really complicated, it's based on angles and what's called trigonometry, but you can measure how far a star is away based on those two images taken 6 months apart. And it gets a bit more complicated than that. But that's kind of awesome, I think. So maths is the way we measure the universe, which is kind of awesome. So that was a video originally posted by Audrey there. Thank you for that, Audrey. And the last thing we're going to talk about, this is something I'd like you to all have a go at some point. I'm hoping I can get this up here. Yeah, I can do. This might crash my computer a little bit. We'll see. But there's a couple of apps that you can use. Now, my favourite one, in fact, I think I can probably show it to you on my phone. My favourite app to use is one called SkyMap. SkyMap. Now, this is one that I've used for a long time. On Android, it looks like this. I don't know if you can see it. It might glitch out because of the green screen. I don't know if it's got green in it. But it's a tiny little icon on Android that looks a bit like that there. But that's a very good app for looking at the stars. And what it allows you to do is basically, you see an interesting star in the sky, you can hold your phone up to it, and it'll tell you what you're looking at that time, which I think is pretty awesome. Sorry, sore neck. But there's a few apps that are a little bit like that. So SkyMap is my favourite. You've also got Star Chart. You've got Stellarium. So these are all apps that you can use in order to look at things in the sky. Now, ones that you can get on your browser aren't quite as good. So I'm about to show you one on Google Chrome here that I don't think is as good, but it's still, it's good enough. The ones on your phone tend to be better. I've never seen better than SkyMap. I think SkyMap is as good as it gets. But let's go back to my browser view. Here we go. So this is what we would see at night from Edinburgh. So what I've done is I've set my location. This, incidentally, is not my address, but if I just click Get Location, it seems to think I live at 30 Crammond Road. So, I mean, don't go turning up there trying to pay me a visit. You're not going to find me there. There's obviously some sort of routing station near there or something, and that's where they think it is. But you can set your location. You can set the time, and I've set this to 11 o'clock at night. So in Edinburgh, 11 o'clock tonight, these are the things that you would be able to see in the sky. So let's close this just now. So, looking around here, it has all the constellations marked in it. So this is the constellation Leo. But the one that's really easy to see, I find, is at least part of Ursa Major. So this part here is called the Big Dipper. Really easy to recognise, I find. Maybe it's just because I'm so used to looking for it. But the Big Dipper, really nice and easy to find. I'm wondering if I can actually turn off some of the features here so that you can't. I'm not sure that'll work. Nah, no worries. But by using certain constellations, and this was part of your work earlier in the week, but I don't think everyone did it. But by using some of the constellations, you can actually do a little bit of navigating. You can find certain useful things in the sky. So the Big Dipper here, if you take these two stars here of the Big Dipper and draw a straight line, or almost maybe a slightly wonky line, you get to this star here, which is a very important star. That is Polaris, or the North Star. Now, it's not super bright. A lot of people think the North Star is like the brightest star in the sky. It definitely isn't. Definitely not. But it is a useful star because it shows us where north is. If you look up at the North Star, then you are looking north. So north, we know, would be this way. Another way you can find it is using the big W, or Cassiopeia. So this is Cassiopeia. It looks more like a big M here. So ignore the lines that they've drawn on. Think of it as looking like a big M or a big W. So up, down, up, down. Hopefully you kind of see that. So M there. Cassiopeia you can also use in order to find the big double. Getting confused. Polaris, the North Star. So if you take the last star in Cassiopeia, this one here, and the last star in the Big Dipper, and draw a line between them, then you find Polaris, the North Star. So all of these can be used for a little bit of navigation, and they were used by sailors for hundreds and hundreds of years, these constellations, which is kind of cool. But certainly if you download Sky Map and you want to know, what is that very bright star in the sky, you can hold up Sky Map to it and it'll tell you what it is, which I think is pretty awesome. So have a wee look at that if you get the chance. Anyway, guys, that is time up. I've rabbited on for far too long and probably bored you stiff, but what do you know? I like space. I think it's kind of cool. Anyway, if anyone in my class wants to have a Philosophical Friday, we've got a chat that we can have at Philosophical Friday. Other than that, I bid you all farewell, and hopefully speak to you soon. Remember, no school Monday, so work will be posted from Tuesday. Take care of yourselves, guys. Get work posted on Notebook, and see you all soon. Bye for now.